WNYC is supported by BEAR. Science is about asking questions, testing, trying again. It's not easy, but it's relentless. It evolves, and that's why science delivers. Learn more at sciencedelivers.com.
Hey, it's Flora, and you're listening to Science Friday. When the James Webb Space Telescope first started sending back images in 2022, something mysterious appeared. Little red dots speckled across the sky. They didn't look like any celestial objects we knew about. So, what are they? That was the question astronomers began racing to figure out. As you might expect, there was a lot of red-hot debate over what these little red dots are, but astrophysicists are making progress. They appear to be black holes, but black holes like we've never seen them before. In a recent paper in Nature, astrophysicist Dr. Rohan Naidu and his team studied one little red dot in particular with the very catchy name of MOM BH*1, and they have a theory about what it is. Dr. Naidu is an assistant professor at the Institute for Astronomy at the University of Hawaiʻi. Welcome to Science Friday.
Thank you so much for having me. Yeah, really excited to be here.
We're so excited to talk about this. I want you to take us back in time. JWST starts sending back these images. You see these little red blobs appearing. Was this a big deal? Like, what was your reaction, and what was the reaction of the field?
So I think it was very exciting because, every time you switch on a telescope to look at an era of the universe you've never seen before, every astronomer is secretly hoping to find the unknown unknowns, things that were never predicted or theorized that just jump out of you. And so the little red dots were exactly this, right? So they were everywhere. And so they probably are something important. Like, we have billions of stars and galaxies and black holes that exist in our astronomical databases. And if you line them up against the little red dots, they don't really match anything. So that was already quite exciting. And our understanding of what these things are is evolving so rapidly. There's a new paper on the little red dots that comes out literally every single day. So we are all collectively as a community really scrambling to figure out what these things are, right? So something like 1,000 papers have been written on these objects in the last couple years. So it's a really dynamic time in the astronomy of the very early universe.
When you say that they're everywhere, are we talking about like in every image back from JWST? Dozens, thousands, millions? What's the scale?
Yeah, so every relatively, deep image on average has one of these objects. We think at least 1% or even more of every galaxy in the early universe might play host to a little red dot. So yeah, that is pretty prolific.
Was there any thought at the beginning that this is like, oh, there's dust on the glass. Geez, what do we do?
It's funny that you mentioned dust. When we first found these objects, we've gone through multiple eras of trying to understand what these objects are. The first series of theories was that maybe these are galaxies that are so massive that, they're challenging our entire paradigm of how the universe works. Then we went to another set of ideas, which is that, okay, they're just like the black holes that we see and love and find in our local backyard around the Milky Way. But there's a lot of dust on them that is making them appear very red. I lived in Boston for a few years, and every summer we'd get these hazy wildfires, wildfire smoke from Canada and from the north. And so you see how the sky becomes this tint of red, right? And so the physics is very similar. This kind of ash takes the blue light out of the atmosphere and makes it appear red. And so we thought the little red dots were basically these enormous dust factories. And now we are on this new set of theories that you referred to, that these are just completely a different species of objects, like none that we'd ever seen before.
I want to get into that in a second, but why are we just seeing them now?
Yeah, there's two reasons for that. One is that the little red dots really seem to be an early universe special. right? So they really turn on immediately after the Big Bang. And by the time you get to the universe around the Milky Way today, they become very rare, vanishingly rare. So you go from these things being in every image of the early universe to them being essentially gone by today. And so that is the key reason, right? So you needed to like build this amazing James Webb Space Telescope and peer back to the cusp of the Big Bang, to the first billion years, to really find this set of objects. The other part of the answer is that indeed, we just did not have any telescope that was powerful enough to reach so far back in time with such clarity till we had the amazing James Webb Space Telescope, and critically, one that can look at infrared light. So light where these little red dots shine the brightest because they're so far away that light becomes very red by the time it reaches the Earth.
You looked at this one particular little red dot. What do you think it is?
So, yeah, we think it's a black hole star. So we think this object is a completely new type of astrophysical phenomenon, right? Like something that we had never really seen before. So it has the quintessential properties of black holes. So, it is glowing with such high luminosity and such high energy that you typically associate with black holes. But then at the same time, it kind of looks like a star. Right. So if you looked at some of the stars around the Milky Way, so famously one of the brightest stars in the night sky, Vega, has these very particular features in its light. It's very bright at its redder wavelengths, and then suddenly it kind of disappears in the bluer wavelengths. And so this object kind of looked like a very enormous version of Vega, while also having all these black hole-like properties. And so we call these objects black hole stars for that reason, because they have the properties of these black holes, also the quintessential properties of stars. And the way we were able to successfully model these hybrid properties in a self-consistent way is if you take an early growing black hole and completely cover it in dense shrouds of gas, and you get your theoretical model to predict, okay, what does that kind of object look like? It looks a lot like the data that we are getting from the James Webb Space Telescope. And so if you think about what a star is a star like our sun is a giant ball of gas with a nuclear reactor at its center that is holding everything up and providing energy to the whole enterprise. So instead here, we have a black hole that is surrounded by this very dense shroud of gas. And the energy source is the black hole. And all its light is being filtered through these dense layers of gas, very much paralleling what we see in stars like the sun. And so it is a completely new kind of object, right?
I mean, is the idea that it's like a black hole at a different stage of its life, like a baby black hole or a toddler black hole?
That's exactly right. So we think this is the beginning. We think we are catching a baby black hole being born, essentially. And so if you looked at, for example, the supermassive black hole at the center of the Milky Way, Sagittarius A star, if you wound back the clock and asked to look at its baby photos, what would Sagittarius A star look like, when it was being formed? It might look like a black hole star, is what the data are consistent with. And this has been a huge mystery for several decades, right? Because in the Milky Way, we see massive stars dying and leaving behind black holes, but they're far too tiny. They're like, a few hundred times the mass of the sun. But then when you look at a black hole like Sagittarius A star, a supermassive black hole that is a few million times the mass of the sun, we wonder, how do these supermassive black holes get their start? What are their baby pictures? What do they look like? And so one possibility that is looking quite promising is that, potentially every supermassive black hole in the universe may have started its life out as a black hole star.
Do all the little red dots look the same? Like, could some be black hole stars and others be something different?
So that is indeed one of the proposals in this work that we've gone on to build on with wonderful MIT undergraduate Wendy Sun led this work earlier this year, where what we showed is that, every little red dot can effectively be modeled with this extraordinary heart at its center, that of a black hole star, surrounded by, the relatively more ordinary stars and gas and dust that you find in generic galaxies in the early universe. So the simple formula that we came up with is that little red dot equals a host galaxy plus a black hole star. What is special about the object that we have in this paper that really let us crack this puzzle is that the surrounding host galaxy, for whatever reason, is being completely outshone by this extraordinary heart. And so we are basically seeing pure black hole star light come out of this object. Versus in all the other little red dots, it's a mixture. It's a mixture of this black hole star light along with light from the surrounding stars and gas and so on. And so it's kind of like you're traveling in some foreign country and you encounter this truly amazing dish. And you're like, wow, this is really special. This is like nothing I've ever tasted before. But you don't quite know why. And then suddenly you go to a spice shop and you encounter, I don't know, maybe the spice is like garam masala or something special. And you're like, okay, wow, this is what makes this dish so fabulous. And so to push this analogy.
I love this metaphor.
So
Keep going.
To push this, the black hole star is the garam masala that is making all these little red dots so special.
Okay, well, we know scientists love to argue on this show. And we know that, a whole new celestial object, that's a big claim. Do you feel like everyone's convinced? Where are we on the road to consensus?
It's a long road. Like what I'll say is that everyone is united in their excitement about the little red dots. I think everyone is willing to concede that there is something special going on here. But exactly what that something special is where some of the debate lies, right? So, for example, in my telling of this story, we are witnessing the birth of these black holes. Whereas there are other theories out there which try to model these things as already formed supermassive black holes in the early universe.
More like adults.
Yeah, already
black
adults.
Holes.
Yeah, and that creates an entire new set of problems because in that line of thinking, the black hole already has more mass than its entire surrounding galaxy, right? Which is pretty remarkable.
It sounds like fun.
Yeah, for sure. So no matter what it turns out, right? There's a diversity of theories out there. But I think everyone is in agreement that we are seeing something truly special and that these are singular objects.
Rohan, thanks for coming on today. This is really fun.
Thanks so much for having me.
Dr. Rohan Naidu is an assistant professor at the Institute for Astronomy at the University of Hawaiʻi. This episode was produced by Shoshana Buxbaum. Do you have any cosmic conundrums you need help answering? Give us a call. 877-4-SCI-FI is our number. We always love to hear from you. I'm Flora Lichtman. We'll catch you next time.